Hey guys, I believe one of the last lessons we learned this term, it's called about L'Hopital's rule, which is a rule about taking limits. And L'Hopital's rule is about the limits of fractions that are in this very specific or two specific indeterminate forms. Those two forms are if the limit is either 0 over 0 or infinity over infinity. And basically what that means is when I have a limit of a fraction like this, like the limit as x approaches some number a of f of x over g of x, that means, and like if that, when I plug, normally the first thing we would do is we just plug in the number to see if we can just take the limit that way. In our limits unit, we learned a bunch of tricks for figuring out limits if that doesn't work. Like you can factor, or you can like multiply by radical conjugates, or you can combine two fractions or something. But L'Hopital's rule is like a much better trick than all of those. And it works like this. If you have one of those limits and you plug in the a and you get 0 over 0, then you can take the derivative of the top and the derivative of the bottom and then try the limit again. L'Hopital said that he claims that this limit is equal to that one, and he is correct. So if you plug in the number and you get 0 over 0, we call that an indeterminate form. And when the limit is in one of those indeterminate forms, you can use this rule. The other indeterminate form that you're going to have to worry about is if you plug in a to these two things and you get infinity on the top and infinity on the bottom. Like, for example, if the top was like x to the fourth and it was a limit as x approaches infinity, x to the fourth when x approaches infinity also approaches infinity. So we'll see a couple of those here in a minute. A couple of things to remember. Basically, we can take the limits of these things by taking the derivative of the top and the bottom and then doing the limit again. That's what L'Hopital's rule is. And the important thing to remember is this. It looks like we're going to use the quotient rule, but we're not necessarily. We might, but in general, we're not. In general, we're taking the derivative of the top and the derivative of the bottom and like leaving them on the top and the bottom. So this is a kind of a straightforward example. And it's one that we learned when we did the limits unit. I just told you guys that this limit was equal to 1. And like, I remember when I said that, I was like, just trust me that this equals 1. And I might have said something like, we'll learn why later. But if I did, now is that time. If I didn't, we're going to learn why. So here's how we would use L'Hopital's rule to figure this out. The first thing we would do is we would try and just plug in 0. That's kind of how we do all limits. If I just plug 0 in here, I get sine of 0 over 0. Just plug in 0 for x. Sine of 0 is 0, and 0 is equal to 0. And this right here is what I would call an indeterminate form. This 0 over 0 does not equal 0. It does not equal infinity. It does not equal 1. It's like it doesn't equal anything. I don't know how to divide 0 into 0. It doesn't have any, it just has no like mathematical sense. So this is called an indeterminate form. And when we see these 0 over 0 or infinity over infinity, those are the two that you should be thinking about. You should use L'Hopital's rule to figure out the value of this limit. So L'Hopital's rule says this limit is equal to the limit as x approaches 0 again. And now we take the derivative of the top and the derivative of the bottom. That is L'Hopital's rule. The derivative of sine x is cosine x. The derivative of x is 1. So this limit up here is equal to this limit down here. That's what L'Hopital's rule says. Now we try again. We try and plug in 0 again. The cosine of 0 on top. The bottom is just 1, so that's just still 1. There's nothing to plug in. Cosine of 0 is 1 over 1 equals 1. So that's the limit. And that's why in that previous unit, I told you sine x over x was equal to 1. And L'Hopital's rule is like the answer. It's like, how did we figure that out? We use L'Hopital's rule. There's a proof of this rule, which we're not going to talk about. So one of the things, the important thing to remember here is that this part, limits have to have these indeterminate forms or L'Hopital's rule doesn't work. So It only applies these indeterminate forms. And for these four, my goal was just to show you how to determine if a form is indeterminate, which is basically just plug in the number. I don't want to take these limits. I just want to plug these in. This limit equals 0, but we're not going to worry about that. We're just going to be like, if x equals 1, I get 1 minus 1 squared over 1 minus 1, which I think is pretty clearly equal to 0 over 0. So this is a form you could use L'Hopital's rule to solve. It would be, to me, that's not a very smart way to do this problem. But the point here is just to show you, you plug in the number that x is approaching into all the x's, and you see if you get the indeterminate form. That's how you do these. So x equals 1 again. So I plug it in and I get 2 to the first over 1 minus 3 to the first. That's 2 over negative 2, which is equal to negative 1. So this, not an indeterminate form. And honestly, once you plug in the 1 here and you see a 2 on top, you know it's not indeterminate, because it's got to look like 0 over 0 or infinity over infinity to be indeterminate. And 2 is not either 0 or infinity. So once you get something on top that's not 0 or infinity, you're like, this is not going to be an indeterminate form. This guy, we had to plug in a 0 for x. So I get 0 squared. The bottom, I would get 2 to the 0 minus 1. 0 squared is 0. 2 to the 0 is 1. So this looks like it's going to be a 0 over 0 situation again. The check here doesn't really mean anything particularly, except that if we wanted to take this limit, we could use L'Hopital's rule to do it. L'Hopital's rule doesn't always give you a number, but it'll tell you, it'll give you a limit. Limit might be infinite or something, but at least it'll tell you that that's what the limit is. This one, x is approaching infinity, so I'm thinking maybe this will be an infinity over infinity. And this one's a little bit weird. I don't really like to write this. This doesn't really make any sense. X can't really equal infinity, but when I say x is approaching infinity, I mean x is getting very, very, very large. So as x gets very, very, very large, the top of this fraction also gets very, very, very large. So I can write infinity with the understanding that I know that this is not a number. In the bottom here, as x gets very, very, very large, 2 to the x also gets very, 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 very large. Anything like 2 to the x minus any number is always going to approach infinity. So this is like 2 to the millionth minus 1, or 2 to the billionth minus 1. Like that's basically 2 to the billionth. So it's infinity over infinity. So if I wanted to take this derivative, if I wanted to evaluate that limit using L'Hopital's rule, I could try that at least, because it's infinity over infinity. And that is one of my indeterminate forms. So I'm going to start off with a pretty straightforward example, I think, which is just these two polynomials that are divided. It's a fraction. If I just plug in x equals 3, I get 2 times 9 minus 7 times 3 plus 3 over, I think it's pretty clear that the bottom here is 0. This is 18 minus 21 plus 3, which I think is also 0. So this is 0 over 0. So I can use L'Hopital's rule to take this to evaluate this limit. Some people might be looking at this and being like, why the hell would you use L'Hopital's rule when you could just factor maybe? Like you should try that first, right? And the answer is 100%. The point of this example is to show you how L'Hopital's rule works. Again, so L'Hopital's rule, L'Hopital says that this limit is equal to the limit of the derivatives of the top and the bottom. Derivative of the top here is 4x minus 7. Derivative of the bottom is just 1. So now I can try plugging in 3 again, and I get 12 minus 7 is 5 over 1, which is 5. So this limit equals 5. And that's how you do this. You get 5. 5 is the answer. Like I said before, for a problem like this, we had some tricks we learned in our limits unit. Like you could probably factor the top and the bottom of that limit and cross off the x minus 3's, and then you'd end up with the same answer. But you can also use L'Hopital's rule. I'm not going to do both ways. I'll make 2 short videos today about that. We'll break this one. I'll do a couple more examples in the next one.